In this video lesson, we're going to look at how to actually solve stoichiometry calculations. So remember that stoichiometry is using mole ratios to solve problems involving the mass of reactants and mass of products. So to do this video lesson, you're going to want a copy of this handout. It says right at the top that we can use mole ratios to calculate the mass of a product if we have the mass of reactant or vice versa. So we're going to start with the example right here, and I'm going to show you the way that is not using the factor label method first. So we're going to determine what the mass of lithium nitride that is produced when 15 grams of lithium reacts with excess nitrogen gas according to this balanced chemical equation. So the very first thing you need to do is write out all your given information. So the first three pieces of given information is the mass of lithium, 15.0 grams, molar mass of lithium, 6.94 grams per mole, molar mass of lithium nitride, which when you do the math is 34.83 grams per mole. And you also know the ratio of lithium to lithium nitride that's involved in the reaction. So from the balanced chemical equation, we know that we have 6 mole of lithium is in a ratio with 2 moles of lithium nitride. The next thing I would suggest you do is take a look at what the problem is asking you and what the problem is giving you and set up your strategy line. So this problem is telling us we are looking for the mass of lithium nitride. So it's going to be at the very end of our strategy line. We are looking for the mass of Li3N. And it's giving us the mass of lithium. So we know that the mass of lithium is over here. We also know that from the mass of lithium, we can very easily calculate the number of moles of lithium. And from the moles of lithium, we can calculate the mole of lithium nitride. I'm just going to erase that and write it out again so I have more space. So that looks better. So from the moles of lithium, we can get the moles of lithium nitride, and then we can get to that mass of lithium nitride. So we're going to do this going from mass of lithium to moles of lithium. We're going to use our molar mass. Going from the moles of lithium to moles of lithium nitride, we're going to use a mole ratio. And then to go from mole to mass, we're going to use the molar mass again. So we're going to solve this problem in individual steps first. So in our first step, right here, I am going to go from mass of lithium to moles of lithium. So I know that the number of moles of lithium is going to be the mass divided by the molar mass. Or the other way that we do it is we take our mass, which is actually 15.0 grams, and we times it by 1 over molar mass, 6.94 grams, and we would get the number of moles of lithium is 2.16. The next thing we can do is we can take this number of moles of lithium and we can determine the moles of lithium nitride using a mole ratio. That's actually going to be step 2 instead of step 3. So I'm going to do my step 2. I'm going to put it in right up here. So step 2, I want to figure out how many moles of lithium nitride I'm going to have using my mole ratio. So my mole ratio is over here. 6 moles of lithium is going to give me 2 moles of lithium nitride. So I'm going to take the number of moles that I calculated here, and I'm going to bring it down here. So if I have 2.16 moles of lithium, how much lithium nitride do I have? So doing that rule we learned with fractions, x divided by 2 is going to equal 2.16 divided by 6. We do the math, x is going to end up being 0.36 multiplied by 2. We get 0.72. So what this means is that we have 0.72 moles of Li3N. Then we're going to take this number and we're going to calculate the mass using molar mass. So I'm going to put my step 3 over here. So if we are looking for mass of lithium nitride, it's going to be number of moles times our molar mass. So we take our number of moles that we solved for over here, and it comes here. We get 0.72 mole, and you could do the factor label method we did up here, and 1 mole, 34.83 grams. So we've used this number right here. We do the math, and we get 25.0776 grams, and we round that up to 3 significant digits, 25.1 grams. So what this tells us is that if we have 15 grams of lithium, we can make 25.1 grams of lithium nitride. So setting up the problem this way is going to give you the right answer, but it's a lot of work. We can solve this problem using the factor label method, just like we solved mole problems before, all in one step. So we're going to start off, we're going to do exactly the same problem. I'm not going to write out our givens again, but I'm going to use the same color so you can see where the steps are happening. So we are looking for the mass of Li3N. We know from our givens that we are given 15.0 grams of lithium. So 15.0 grams of Li. And we know that we need to take that mass and convert it into molar mass. So we're going to do the red step first. So I'm going to convert our mass to number of moles using molar mass. We're going to go in 1 mole of lithium. We have 6.94 grams of lithium. Then we need to convert those moles of lithium to moles of lithium nitride. So up here, right here, we have moles of lithium. So that means we have to arrange our mole ratio in a way to cancel out number of moles of lithium. So we put 2 moles of lithium nitride on top and 6 moles of lithium on the bottom. Now, if we stopped at this point, we've successfully calculated the number of moles of lithium nitride. If we put this all into our calculator, we would get 0.72 mole. But we're not done. We need to calculate the mass. So we have to then multiply times our conversion factor for molar mass. So we have moles of lithium nitride on top here. So we have to put the moles on the bottom. So we're going to have 1 mole of Li3N on the bottom, and we're going to take that 34.83 grams of Li3N and put it on top. So now I can punch this whole thing into my calculator and solve the same problem in one step. I just want to remind you, you need to put brackets around all of these things. So you punch this into your calculator and you get exactly the same number, 25.0776 grams, and you round for significant digits and you get 25.1 0.1 grams. And then for good form, you would write your therefore statement. Okay, so when you have this down, flip your page over and we'll do the next example on your handout. So in example number 2, it's asking us how many molecules of oxygen gas will be produced if 12 grams of water decomposes. So in this case, we do not have a balanced chemical equation. So we need to write a balanced chemical equation for the decomposition of water. So the balanced chemical equation is 2 water molecules reacts to produce 1 molecule of oxygen gas and 1 molecule or 2 molecules of hydrogen gas. So now you want to write out any piece of given information that you have. Remember, you're being asked for molecules of oxygen and you've been given 12 grams of water. So including your givens, the molar mass for oxygen gas and the molar mass for water. The other thing that you should include in your givens is Avogadro's number, because it's asking you for molecules of oxygen. So once you have your givens written out, including your mole ratio for water to moles of oxygen, start with your strategy line. So it is asking you for molecules of water. So you know that the very last thing in your strategy line is molecules, it's asking you for molecules of oxygen. So molecules of oxygen. It has given you the mass of water. So over here you have mass of water. From mass of water, you know you can determine the moles of water. And you can do that using its molar mass. From moles of water, you can get mole of O2 using a ratio. And then from moles of O2, you can get molecules of O2 using Avogadro's number. So now we start our line. We are looking for down here number of oxygen gas. So we start with our only number that is not a conversion factor, which is given in the problem, the mass of water. So 12.0 grams of H2O. And that is going to get multiplied by the molar mass of water, 18.02. So right here. So we have to put the 18.02 grams on the bottom, and we need to write that it's grams of water, and we'll be left with mole of water. So if we stopped the work at this point, we'd have successfully calculated number of moles of water, but that's not what we're looking for. We need to keep going. We need to convert the number of moles of water to the moles of oxygen gas using a mole ratio. Because we have moles of water here, we need to cancel it out. So that means that the 2 moles of water is going to go on the bottom, and the 1 mole of oxygen gas is going to go on top. So if we punch this into our calculator, we would have successfully calculated the moles of oxygen gas, but it's asked us for molecules. So we have to use our Avogadro's number and put it in here to calculate the molecules of oxygen. So we have moles of oxygen on the top right here that we need to cancel out. So that means that we're going to put 1 mole of O2 here, and we're going to have 6.023 times 10 to the 23 molecules on the top. So now you take this and you punch it into your calculator, but you have to use brackets. You need to put a bracket here, you need to put a bracket here, And you might want to consider a double bracket here. So you punch this into your calculator and you're going to get 2.00 times 10 to the 23 molecules of O2, and therefore you're going to write your therefore statement. Okay, so that's the second type of using a mole ratio. The key to remember for stoichiometry is that you're always going to have a mole to mole in the middle of your strategy line. Doesn't matter what it's giving you and what it's asking for, there's always a mole to mole and a mole ratio in the middle. So go ahead and try example number 3 if you like. I'm going to keep this one to teach it to you or to go through it with you in class. But you now have examples of the 2 different types of stoichiometric equations. So give your practice a try and I will answer any questions in class. And that's the end of this video lesson.